Hello everyone, we're back to Lecture 6, Sensing and Visualization in RAWs. Today we're going to introduce the concept of rviz. rviz is a powerful visualization tool, as you can guess from its name. It's really designed to display sensor data on screen. So it's really different from Gazebo. Gazebo is a simulator where you simulate the physics of a world, including the mass and the velocity and the acceleration. In rviz, you can see the robot through the robot model, but what you really care about is looking at all the data. We're going to look at, for example, LiDAR information, camera information. And so it's going to be helpful to see what's going on inside the robot. rviz also lets us seize the robot pose, or even more specifically, all the poses of all the links in the robot. And sometimes we can superimpose graphics. Sometimes those will be markers or images that are coming in from perceptual nodes, cameras, LiDARs, or depth cameras. And rviz will also have a server that lets us interact with mouse clicks on different parts of a robot or even an object. If you want to run rviz after you've started ROS core, you can do that simply by typing ROS run rviz rviz. Let's take a look. So if I start ROS core like this, I can just open rviz in this way. Right now we'll just get an empty window because we haven't really ran anything. Here on the left side we have something called the displays view, and here yours might appear empty, but displays can either be added, as you can see down here, or removed. So for example, I could click on this one and remove it, or click on this one and remove it, robot model, remove it, or I could just add that one again. When you click on adding, a long list of visualization displays will pop up, and you should select one according to what you need to show. In this case, for example, robot model, and it will be added right here. Some important things to note is this one on global options. You'll have to be defining what a fixed frame will be, and so this is a string. Sometimes you can simply choose one from the drop-down menu. Other times you'll need to write one in yourself. Robot model will be looking at the ROS parameter server, and specifically for this default parameter we call robot description, that is loaded from our URDF file, as you have seen before. Okay, and then we'll go through some of these later. This left display view can be minimized and maximized by clicking here. And then on the right side we can also open this views panel that lets us change the way we interact with the world. For example, a left mouse click lets you rotate about a point. The middle mouse button lets you pan around, and then the right mouse click button lets you zoom in and zoom out. Okay? Here's a picture from rviz showing the Atlas humanoid robot, and we can visualize surfaces as from the LiDAR sensor. Here LiDAR sends out rays of light striking different surfaces, including the robot self, the table, cups, and also the floor surface. You can see that each one shows up in different colors, the floor being red, the table yellow, the cups having a couple of colors, green and blue, and then the robot blue and purple. why do we have different colors? This is being measured according to, or being colored according to z-axis values. So the highest z-axis values around the head show up in purple. Then we transition to blue, then light blue, green, yellow, and at the bottom red. The sensor data like this can come from different sources, including the real robot, or simulated data like Gazebo, or even recorded raw spec data. rviz can also colorize connect data, depth data, according to height. And you'll see that here the simulation is always going to be consistent with the real robot. So the robot poses should be the same both in simulation as in the real robot. And thus the sensor data will also be very realistic, helping you to capture the true depth of a robot or an object in the environment, both in simulation or in the real robot. Note that to do this, Gazebo or the real robot or different nodes in ROS will constantly be using transformations to properly place both objects and views in the world. The first question we want to ask is, how can rviz show the robot model? As mentioned before, rviz is using the robot model display view. And within this display, there is an option to fill in the robot model. That option should be filled with a parameter with the name robot description. If you want to learn more about robot description, click on this link to learn about some details. It's a raw standard that we would place the URDF loaded file on the parameter server under this name. So once we load the URDF file onto the parameter server, all the kinematic information and visual information for the robot is loaded. And this is true even if Gazebo has not been launched, because that information really comes from the URDF file. Gazebo will also use the URDF file to create its own models. That means we can use rviz even if Gazebo has not been launched. However, we won't have access to real robot motions, real simulation robot motions, unless Gazebo is started. And if we're using a real robot, we can know that the robot pose is going to be consistent with simulation, and we will be able to access pose information from the joint states topic. This is a standard ROS topic where joint data is stored. For example, joint positions, joint velocities, and joint accelerations. This might be useful for the arm, might be useful for a hand with his fingers, might be useful for a leg. And also, the robot state publisher, as we have seen earlier, will take in the joint state information and then output to TF. Sensor data will follow the same logic. We will have consistent data across real robots and simulation for the most part, and it will be updated consistently. rviz can be useful for visualizing the robot, but also for debugging hardware. For example, you might have a newly designed real robot where you turn off the motors and then manually move the joints. And so as you move the joints, you will be able to see the same motions in the simulator and check to see if there's any inconsistencies, see if the joint limits are correct, make sure that your kinematics are displaying properly. You could also record data from the robot and then play it. And in cases where there might be failure, you can pause the visualization, check for instability, check for controller oscillations, and test different poses, check joint limits. So it'll be a very useful debugging hardware. You'll see more as we go through this course. Also, rviz can be really useful for understanding the robot model. Let's say you open a Baxter for the first time, or any complicated robot, and you want to understand more about the kinematics. You want to know how the links and the joints are connected. You can use the robot model display or even a TF display to highlight, to show or remove each of these individual links, show their axes, and understand where the X, the Y, and the Z axes are pointing. And this can be really useful. Now, you know, we always need a reference point for everything, a 0, point. This can be thought of as the world frame in rviz. And so sometimes that world frame needs to be defined through you using what is called a static transformation, or sometimes some node will do that for you. When we use Gazebo, a world frame is automatically created. And our real robots will use static transformations between what is the robot base and the world frame. Say, for example, for Baxter, the torso, like the chest area, or what would be the belly button area in the middle of that base, that's what the base of the robot is. And so you would have a transformation from the world to the base. And that could be whatever you want. It could be a 0, transformation, or it could have some other parameters. Okay.